Hello, I'm Kenny Johnson, and this is my take on a local alarm system. This is my EET402 Capstone project, and I basically wanted to design a universal device, a universal alarm system that can take any kind of device, any field device can be hooked up, and it will pull the inputs and monitor the zones. And this is all based upon the Motorola 68HC11. And it's running in extended mode on the Fox11 EVB board, and I'm using all the peripherals that come with that EVB board. Right here we have the keypad to arm and disarm the system. Port B, the LED indicators right here, they're actually used just to distinguish which fault is actually, which zone is faulted at any time, and the LCD is used just as to display what state the panel is in at any point. And basically that's the way everything works. It's all about states. I have multiple states that we'll go through as I show you everything. Right here on the breadboard, these white wires are all my inputs, and they're routed in the port C. And now typically with extended mode with the 68HC11, you lose port C, but the EVB board allows port C functionality back with extra registers and extra chips to re-enable those lost inputs and outputs. And this is mainly because of how powerful the power of the 68HC11 is. All about the inputs and the outputs. Right here I actually have a 4.7K current limiting resistors. There's 8 of them to protect each zone, and that's just to keep the current down as a precaution. The chip itself is very low tolerance, and anything over 5 volts and it just will not take it. You have to be very careful with inputting any kind of voltage and outputting any kind of voltage for that matter. And so I tried to be as cautious as possible. Right here I actually have an LED, and this is just for an alarm output. This is just used as a visual indicator, and I'll go through it when we enter the alarm state later. Right here, this board below is actually what allows me to translate any type of field device and turn it into a zone effectively and monitor it through the chip. And this is the outputs right here, and basically I have 5 volts being routed through here, and when the relay fires, it will route 5 volts through port C into my input, and it can be seen as a zone. Right here I have some shocky diodes, and this is just more precaution. When those relays switch, I was just worried about any kind of reverse current getting into the chip or anything like that. Switching speeds, it all comes into play, so I try to be as careful as possible. These are the inputs, and any dry, normally open, normally closed input, it can be accepted, and it just needs to see a closure. Once it sees a closure, it will actuate these relays, which will route the 5 volts where it needs to go. And you can actually use a normally open or normally closed device. It doesn't matter either way, because we have normally open and normally closed outputs up here, so I can choose which way. So the input actually needs to see a closure, but you can choose and switch it back and forth when it outputs the voltage. Right here I have a Altronix MOM 5 board, and this is used for the alarm output. And basically the alarm output is routed through port A, and it sends out 5 volts through pin PA5 to be exact, and it will in turn trigger a single relay, and this relay will allow 12 volts to pass to any field device. I'm using a piezo here, and this runs off of 12 volts DC, and basically you could use whatever you like. You can use a horn, a strobe, multiple devices. It doesn't really matter as long as it's 12 volts DC. I have a motion detector on zone 3. I have a push button on zone 2, and a door contact on zone 1. And I just use these for an example, but you can actually use 8 zones. I mean, this any 8 zones at any time could be monitored, and it will recognize any dry contact that is input into the board. As I was saying earlier, there's multiple states, and we have the fault state, which of the disarm state, and this effectively stops you from being able to arm the panel when there is a fault. That way, if you left the door open or anything like that, it would stop you. And now we have the disarm ready to arm state, where it's waiting for the input at the keypad, and a simple one press on the keypad, and it will give you a 10-second delay, and that way you can leave the premises if you needed to. Give you enough time to get out the door, and you could actually set I only set it for 10 seconds to speed along things, but you can typically set that for a minute, a couple minutes, and at any time when it is armed, you could, just by pressing a 0 on the keypad, it will disarm. And I'm going to go ahead and arm it again and set off the alarm. Now, as far as the alarm goes, I set it to pulse, so it would attract more attention. Anything hooked up to the MOM5, it will pulse and constantly turn on and off, and that just gives you a more wow factor. And then once the alarm is set, the LCD actually updates as well. And there's my LED that I mentioned earlier that I just added as a visual indicator, as well as the audio. And we can disarm at any time. In any of the states, we can. I tried to make it so that it would pull the keypad and constantly update the LCD, so you always have some kind of you can always know what state the panel is in at any time. And my name is Kenny Johnson, and I hope you like my presentation. Thank you.